Hi there, this is Mr. Delovit, your physics teacher. So today we look at mechanics and especially how to calculate the area under graphs under linear motion. Now I said in all the graphs you need to understand to differentiate between velocity time graph, displacement time graph, and acceleration time graph. So in solving this, so what expecting you to do is that first thing is first is you have to watch the other videos about graphs to get understanding and about linear motion to get understanding. So the first thing you have to know, okay, this graph is velocity time graph and it's against time. And I said for velocity time graph, the area under the graph is displacement, or you call distance if it's a speed time graph, right? And for acceleration time graph, the area under the graph is velocity. So it depends on what you'll be looking for. So they can give you a graph like this in this example that we have here. Now, in doing this graph, the first thing you have to understand that you have to look at, you have velocity here. This is the time. They have given numbers 2, 2, 4, 6. So calculate now. They'll ask you to calculate now the distance. In this type of question, they can ask you to describe the motion first. Now, if you want to know how to describe this motion, watch the previous video on graphs and you see how I've described this motion. Now we are focused now on calculating the area under the graph. This is the area. This is the area under the graph. So how do we calculate it? For us to calculate area, and this area under the graph will give us what? Will give us displacement or distance, depending on what they ask me to look for. Now, how do you get so the area? So displacement will be equal to area under velocity time graph. Now, how do you calculate area? So now we equals now you have to divide into different polygons that you can easily evaluate. I divide like this, and I'll divide like this. So you see that this man is A, this is B, and this is C. So equals the area of A plus the area of B plus the area of C. That's how I get it. My displacement equals the area of A plus the area of B plus the area of C. So you see that this man represents a triangle. This one represents also what? A triangle. So, and this one in the middle represents what? A rectangle. So what's the formula for the area of a triangle? So we have half base times what? Height. Plus area of B is a rectangle. What's the formula? Area, length times width. Plus it's a triangle. Half base times what? Height. That you get it. Now, what will be our base now? Yeah, this is my base. My base now will be the value from 0 to 2. What will be my height? My height will be the value from here to here, which is this value, this number here. Now, the same here, what will be my base? My base will be between 6 and 4. What will be my height? My height will be from here to here, which is from here to this number. Now, here, what will be my length? This is my length from between 2 and 4. That will be a length. What will be my width now? My width now will be from 0 from here to here, which is same as from here to here. As simple as that. So now what happens if we have base? What my base is from 0 to 2 will be 2 times 2 times my height. My height is 2. Plus, what's my length here? My length now will be what? 4 minus 2. It will give you what? 2 times now the width. The width from here to here will be times what? 2. Plus half. The base now. What's the base? The base now is from 4 and 6. It is 4 minus 6 to give you what? 2 times height. The height now gives you what? From here to here, will give you what? 2. Right. So these 2 cancel this one. So you left with, or you left with, with 1 times 2 will give you 2 plus 2 times 2, 4. And put the brackets as differentiates. So 2 times 2 will be 4, and then plus this one cancel, you left with what? You left with what? 2. So your answer will be 2 plus 4 plus 2, which gives you what? 8 meters. So that is how we calculate the area under a graph. Now, if you have a situation like this, let me say this is acceleration time graph, and then we have a situation like this, if like this. So they ask you now to calculate now. They ask you now to calculate what the okay, let's say the value is 20, and they have 10 here. They can ask you now to calculate now the velocity time graph. Now, sorry, to calculate the velocity. Now, for you to calculate the velocity, you have to go your knowledge that velocity in such situation will be equal to what? The area under acceleration time graph. And what's my area now? So what my area, you have to break it down, bring it down. So you see that this area now here forms what? A triangle. That's a triangle. So my area now will be half base times what? Height. Now what now is your base? Your base now will be this one. Which means from 0 to 10 is what? From 10 is 10. So we have, let me change we have times what? 10 times now from here to here. From here to here now the height will be from here to this value that you have here, which is 20 times what? 20. So the 2 here cancels, the here goes 5, and then you're going to have 5 times 20, you have 100. 100 what? Meters per second. So that's what we have as the velocity graph. So this is how we do area under graphs. You have first thing you do is you do what? You identify the different polygons. Divide them. Make sure you have that polygon that you can look for the area, or like a triangle, rectangle, parallelogram, and so on and so forth. Then when you divide them, you know the area under the velocity time graph is displacement. The area under acceleration time graph is what? Velocity. So when they give you that, find the area under the graph, or say find, they will not say find the area under the graph, they always say you find the displacement or find the velocity. When they say velocity means that, and they're giving acceleration time graph, you're looking for the area. If they give you a velocity time graph, find the displacement, you're looking for the area under the graph. Thank you for watching, and stay tuned for more enriching videos on this.